So this is a 2025 paper 1 question 2, and we're given this function and we're asked to differentiate it. So basically, f prime of x will be equal to, and when we're adding a bunch of things together, we just differentiate each one individually. So the derivative of 6 is just 0, because it's a constant, it doesn't depend on x, it doesn't change at all. The derivative of x squared is 2x. And for the derivative of sine of 4x, we have to use the chain rule. So we do the derivative of the inside function first, and the inside function is just 4x. So we're going to have 4, because that's the derivative of 4x. And then we're going to do the derivative of the outside function, which is sine, and the derivative of sine is cos, and then we keep the inside the same. And that's the derivative for 5 marks. For part 2 then, we're asked to find the equation of the tangent at the point where x equals 0, and we're told to give the line in a specific form. So the first thing we need to know is what is the equation of a line. So if you go to page 18 of the Formulae and Tables booklet, you can see that the equation of a line is given by either of these two things. You can actually use either. I'm going to use the top one because that's usually the one that, probably the one that you've encountered. So it's y minus y1 equals m times x minus x1. So we need to know two things for this. We need to know a point, x1, y1, and we also need to know the slope m. So remember that the derivative is just the slope, so we can use this to figure out what m is. So if we want the derivative, if we want the line, the tangent when x equals 0, we need to know what the slope is when x equals 0. So we can figure out what is f prime of 0, and that'll be our slope m. So we can just replace everything with 0. So we'll have 0 plus 2 times 0 plus 4 times cos of 4 times 0. And when you put that into your calculator, you should get an answer of 4 for the slope. Now, to figure out a point on the line, well, we know that it's tangent to the curve, which means it touches the curve where x equals 0. And if here's just a quick example of what the curve would look like. At the point where x is 0, y is equal to 6. And we can figure that out, the point on this curve, what it is. What is the point on the curve when x equals 0? Well, we can just take the original function, which is f of x is that, and we can just sub in 0. So what is f of 0? That'll give us the y value. So we'll have 6 plus 0 squared plus sine of 4 times 0, which is just 0, so we get 6. So indeed, a point on the line is going to be 0, 6, which is going to be our x1, y1. And then we can just sub everything into this formula, and that'll give us the equation of the line. So we can say y minus, and then y1 is 6, equals m, which is 4, times x, minus x1, which is 0. And then we have to rearrange this to be in the form ax plus by plus c equals 0. So we can need to bring everything to the left side when we simplify. So y minus 6 is equal to 4x. Or in other words, we're going to have y minus 4x minus 6 equals 0. So that's, or they want the x first, sorry. So we're going to actually write that as minus 4x plus y minus 6 equals 0. And that's the correct answer. And of course, you could also, if you did this out and you accidentally multiplied across by minus 1, it's also completely valid to have this as well as your answer. So that's just if you multiply the whole equation by minus 1, both of those are correct. In part B then, they kind of test your conceptual understanding, I suppose. So they give you this graph and they ask, when is g prime of x greater than 2? So remember that g prime of x just means the slope. So basically what they're asking, so this is the slope, when is the slope bigger than 2? Well, we can see there's kind of two portions to this. We can have this red line here, and we have this green line as well. So let's see, what is the slope of that red line? Well, for the red line, the slope is, of course, rise over run. And you can see that it increases by 1 unit here, but the run is 3. So for every 3 units it goes across, it increases vertically by 1 unit. So for every 1 rise, there's a run of 3. So clearly at this point, g prime of x is not bigger than 2 because this is less than 2. So let's have a look at the slope of the green line. So for the green, again, we're going to have rise over run. So you can see that it rises by 3 units when the run is 1 unit. So you can see that it goes from 1 up to 4, but it vertically and then horizontally goes from 3 to 4. So we have a rise of 3 over a run of 1, which gives us 3. So here the slope clearly is greater than 2. You could also use the slope formula if you want, y2 minus y1 over x2 minus x1. You can just sub in the points, like this point up here is 4, 4, and you can do it that way as well. So clearly, the slope is bigger than 2 in this green portion. So the slope is bigger than 2 when x is between what values? So the range of values. So when x is between 3 and 4, clearly, because you can see here x is 3 and here x is 4, and between those two values, the slope is bigger than 2. And they weren't too picky about whether you said less than or equal to, or if you just said less than, you could also have that, because it's not very clear from the graph what the slope is here. Technically, it should be just less than, because as you can see, at 3, it's not clear what the slope is, because, you know, is it a third or is it 3? Because it's kind of at the layover point of both of them, but they weren't picky about it, but technically, this is the correct answer. For part 2, they want you to find the value of g of 3 and give your answer as a fraction, and they want you to show your work on the graph. So first of all, we can work from the inside to the outside. What is g of 3? Well, this line is our function g, and so when we sub in the x value 3, so g of x, so here if g of 3, x is going to be 3, so here g of x, and we're looking at g of 3, the x value is 3. So when the x value is 3, to show your workings, you draw a line up and read out what the y value is. So the y value is 1, so g of 3 is equal to 1. That's the first thing you'd write. And then we want g of 3. So we're going to have g of 3. And we know that g of 3 is 1. So we want to figure out what is g of 1. So again, you can use the graph to figure it out. And you draw a line across. And turns out that this number here is 1/3. So you'd give your answer as 1/3. Might be asking, why is it 1/3? Well, that's because the slope is 1/3. So you can see that the value at 3 is 1. And it's a straight line, so at 2 it's going to be 2/3, and at 1 it's going to be 1/3. So that's how you would do that. Then in part 3, we're asked to sketch the inverse on the graph, and they ask us to label it as well. And then it gives a hint about axial symmetry, but I think there's an easier way to do this. So basically, the inverse of a function is that you kind of want to do it backwards. So here, for example, the previous part kind of helps us. We know that g of 3 is equal to 1. So our new function should take in 1, so I'm going to call it g inverse. If I plug in 1, I should get 3 out, because it does the opposite of what this function does. So that gives us actually a point. When we plug in x equals 1, we get y equals 3. So x equals 1, y equals 3, that's a point here. Another thing we know is that g of 0 is 0 clearly, because you can see down here in the bottom left, when you plug in 0, you get 0 out. So if g of 0 equals 0, that means in the inverse, when we plug in 0, we should get 0 out as well. So we also know that this down here is a point. And then finally, we also know when we plug in 4, we get 4 out, so it should be the same when we go backwards as well. And then you can just connect these lines. So because there's straight lines here, we kind of just draw straight lines as well. So you can just draw a straight line up like that. If I could actually draw a straight line, just imagine that's a straight line, and then a straight line like that. So it should look like that when you're done, and if you want to use the way that they told you with the axial symmetry to see what that means, if we draw the line y equals x, which is here in green, also they told us to draw and label. So it's actually very important that you write y equals g inverse of x up here at the top. This green line here is just the line y equals x. And what it means by symmetry is, as you can see, for example, this is 1 unit down and 1 unit to the right over here. So if we kind of do symmetry through the other side, it ends up over here. Instead of going down 1 and right to the 1, we go left and up by 1.